Hi, welcome to the lecture on sampling distributions. So the first thing that we want to talk about is what is a sampling distribution, and we want to talk about what the two statistics are that we're talking about, P for proportion and X bar for the sample mean. Sampling distributions are representations of all possible combinations from a sample size n. When you sample from a population, you may not always gain the true mean or proportion, so we use facts about that population to determine how good our sample is. Excuse me one moment. Sorry about that. Rules and facts. Come on. Rules and facts. All right, so sorry about so much information being on this slide and all crammed in together. The mean of the sampling distribution of the sample mean X bar is the value of the population mean mu. The standard deviation of the sampling distribution of X bar is the standard deviation over the square root of n, where we have the population standard deviation and the sample size. We call that the standard error. We call that the standard error of the mean. For a normal population, the sampling distribution of the sample mean as X bar is distributed as normal. When the sampling distribution of X bar is normal, we may standardize to produce the standard normal variable Z, which is X bar minus the mu over the standard error. It's this guy right here. That's a really important formula to remember. So let's talk about what the central limit theorem says. The central limit theorem says given a population with mean mu and the standard deviation sigma, that's sigma, right? The sampling distribution of the sample mean X bar becomes approximately normal as the sample size gets larger. Wow, that has been a typo for the ages. Oh, God. So the sample size gets larger regardless of the shape of the population. We consider a sample size of 30 or greater large enough to sample to apply the central limit theorem. We have three cases. If the population is normal, then the sampling distribution is normal. If the population is not normal or the distribution is unknown and n is greater than 30, then the sampling distribution is approximately normal. And if the population is not normal or the distribution is unknown and n is less than 30, we do not have enough information to determine the shape of the sampling distribution. So you're going to need these three cases to do the work that is assigned to this section. So remember these three cases. This is important. Okay. Sampling distribution for proportions is where we have something over a number of people. So X represents the number of individuals in the sample that have the particular characteristic. Is that even spelled right? We use p hat to estimate the unknown value of the population proportion p. So when we talk about that, the standard deviation or the standard error for a proportion is p times 1 minus p. You might even see it as p q over n, where q is equal to 1 minus p. Okay. The size proportions, the size meanings, is n and p, the number of the sample size plus the proportion needs to be greater than or equal to 5, and then n and q need to be less than or equal to 5. We're going to be greater than or equal to 5 as well. So the minimum sample size required to produce approximate normality in the sampling distribution of p hat is the larger of either of these two formulas. So let me show you what the z looks like. So we got p hat minus p over the square root of p times 1 minus p over n. So now let's look at an example. If possible, find the indicated probability. If not possible, explain why. I'm sure these pages don't line up with the text. These are probably from the second edition. Scores on a psychological test are not normally distributed with a mean of 100 and a standard deviation of 15. A sample size of 25 is taken. Find the probability that the X bar is between 94 and 103. We can't do it. It's not normally distributed, and we don't have a big enough sample size. But if it was normally distributed, then we would be able to find it. So let's find it. I am gonna erase that. I am going to draw a bell curve. And I'm going to, I know the mean is 100. So I got 94 and 103. I don't know why it's glitching like this. I apologize. Whatever. We know it's 100. So I'm looking for the area between these two guys. So I need to find the z of 94, and I need to find the z of 103. So that is going to be 94 minus 100 over the square root of 15 divided by 25. So that's negative 6 over the square root of 15 over 5. And then I'll put that in a calculator. And then this is going to be also, this is 103 minus 100 over the same standard error. And that would give us 3 over 15 over 25. Alright. So I'm going to call up my calculator now. My handy dandy calculator. I need this in scientific mode because I need a square root. Where are the square roots? There they are. Alright, so we've got 94 minus 100 minus 6 divided by parentheses the square root of 15 square root, no, clear. I hate this calculator. So we go 15 divided by 25. And then we're going to take the square root of that. And that gives me negative 7. That's a really big z. Let me do it out on a calculator. I'm going to pause this and do it out on an actual calculator. All right, I verified on a calculator, and this is indeed negative 7 points. Where's my history? Negative 7.75. So that's highly unusual. And the z-score for this guy is 3.9. So it's still also really unusual. But that's how you apply that formula to see if those samples are there. So this is probably going to be a 99% chances between 94 and 103. But I'm not going to do the norm dis stuff to figure it out. But you can do that if you want to, because there's more examples that I got to get through. So onward. Scores on a psychological test are not normally distributed with a mean of 100 and a standard deviation of 15. A sample size of 25 is taken. Find the 50th percentile sample means. That is a trick question. That's 100. Scores on a psychological test are normally distributed. Yeah, so we can't figure it out in 12, but when we do it in 13, they're normally distributed. That is 100 because it's the 50th percentile. Let's talk about cocaine and heart attacks. Now, I do believe that I've assigned you one very similar to this. So the American Medical Association reported during the first hour after using cocaine, the user's risk of a heart attack increases nearly 24 times. The average age of people in the study who suffered heart attacks soon after using cocaine was only 44. That is about 17 years younger than the average heart attack patient. Of the 38 cocaine users who had heart attacks, 29 had no prior symptoms of heart disease. Assume that the standard deviation of the age of people who suffered heart attacks soon after using cocaine was 20 years, and we take in a sample size of 38. Find the 97.5th percentile of mean age of heart attack after using cocaine, and find the 2.5th percentile of the mean age of the heart attack after using cocaine. So what we're going to do is I'm going to add a slide here so I can do some math. Insert new slide. We're going to delete, and we're going to, there we go. Of course, you guys all probably just saw the course shell, but that's okay. So we know that the mean is 44. So mean is 44. No. The mu is 44. Standard deviation is 20. We want the 97.5 and the 2.5 percentiles. And we have a sample size of 38. Okay. So 97.5. Bell curve. I want to find a z associated with 0.9575. And then I need to also find a z associated with 0.025 for that area. So I'm going to go to Excel for that. Come on. New blank workbook. And we are going to go equals norm dot s dot inv because we're talking about a sampling distribution, the standard normal curve. All right, so norm dot s dot inv of the probability is 0.975. That gives me a z of 1.94. And then I'm going to do it again. Negative 0.195. So I think these are both 1.95. 1.95 and negative 1.95. So they are the outer boundaries. So now we use z equals x bar minus mu over square root of standard deviation over n. We know 1.95 equals, we're looking for x bar. We know it's 44. Are we looking for x bar? Yes, mean age. We're looking for x bar from the 95th percentile. 97.5th percentile, I should say. And that would be 20 over 38. That crunched out in a calculator. We got 20 over 38. Okay. Times 1.9. I'm going to pause the video and calculate. I got x bar equals 45. Okay. So the lower end of that is going to be, drumroll please, is the other x bar is 42.56. So, moral of the story is don't do cocaine, guys. You'll have a heart attack in your 40s. So, did we find everything? We found it. That's awesome. Now let's look at women and depression. I also gave you a problem like this as well, if it's not already the actual problem. So, according to the National Institute for Mental Health, 12% of women are affected by a depressive disorder each year. Suppose we take samples of 49 women. Answer the following. Find the probability that p hat is greater than 0.15, where p hat represents the sample proportion of women who are affected by the depressive disorder each year. Calculate p hat, the probability of p hat being between 0.12 and 0.15. Use your answer to calculate the probability of being 0.1, the p hat being less than 0.15. And find the 5th and 95th percentiles from the same proportion. So that one, this one, we're going to go back. And remember I told you you needed this formula and this formula. So we're going to take this formula with us, p hat minus p. And we're going to, I'm going to keep those ink annotations. Insert new slide. All right. Sorry about that. All right, so we want, all right, so P is 0.12. We're looking for p hats. We got an N of 49. All right. We want to find p hat is greater than 0.15. So p hat is greater than, no. Greater than 0.15. Then we want to find between 0.12 and 0.15. And then 5th and 95th percentile. All right. Oof, that handwriting is atrocious. I am out of practice. Still atrocious. Close enough. All right. So first of all, we need our z. That's p hat minus p over p times 1 minus p over n. So let's find 0.15. Z of 0.15 equals 0.15 minus 0.12 over 0.12 times 0.88 over 49. That's going to calculate out to 0.3 over something. So let me pause the video and get that. So the standard error for this has come out to be 0.046. So I'm going to go 0.3 divided by 0.046. You can't see this calculation. That is 6.52. 6.52. So that is highly unusual for that sample to be that large. So I can go and get the precise amount from Excel by going to Excel, and I can go equals NORM dot s dot dist of my z, which is 6.52. My cumulative is true, and that is a large probability. I can do that again for our 0.12, but that's just going to come up as 0 because that's our mean. So that probability that it's greater than 15 is rather large, or rather small, I should say. So less than 15 is going to be rather large. So that is that lecture. I hope it was informative. I hope you have a great day.